Hi, I'm Richard Ma, and this is Nathan and Ho Ming, and we're Beacon Thugs in Harmony. So, going back to DevCon, we heard about Ethereum 2.0, and we thought it was really cool. And we watched this live talk by Justin Drake that explained it. And at the end of the talk, I thought I got it, but I didn't really. So, before this event, at 8 p.m. at night, we decided to look at this specification for the VDF Randomness Beacon for Ethereum 2.0. We're like, we do not understand that. So what we did to learn about this, and we didn't really try to go for any bounty, was we tried to implement Ethereum 2.0 and make a simulation. So you can actually go to this right now. It's at beacon-chain.com. And this simulation, it has several components. So what I'll do is I'll go through our React web app, and then Nathan will go through our backend where we actually have a Python library that runs through the simulation. So on the top right, there's these genesis constants. So in Ethereum 2.0, you have number of shards. You have, so for us, we have number of simulation epochs. We also have the number of slots per epoch, where a validator proposes a random number. And then for this one, we also have the number of validators. So we have 10 validators, 3 shards, and on the bottom here, what's really cool is that you can actually step through the operations of Ethereum 2.0 live here. And you can go back and forth. And you can watch as you go through the random mixing process through to the VDF processing until you reach the proof buffer. And if you look at the current random seed there, you'll see that the new random unbiasable random seed is now generated. And this is really used to pass on the randomness to the rest of the Ethereum 2.0 shards so that the whole system can work. So with that, I'm going to pass it to Nathan to explain our Python.
Yes, so the important thing that we've done here is that we've implemented the algorithm faithfully. We haven't implemented the algorithm completely. What that means is that we take all of the ceremonies, all of the algorithm steps, and we do implement them as if they would be implemented on the blockchain. That, for example, the VDF, we do in fact generate the ceremony, the RSA ceremonies that generates the key that can be used. And we also do calculate the RSA signing for each step. The reason that this is so important is that this is such a complex mechanism for generating on-chain entropy, which is a core feature of the proof-of-stake system. And it's such a difficult thing to understand that we need a way to actually explain it to the people who want to advance the state of the art. We can't, if nobody understands it, if there's no way to act as a debugger and go through it step by step, seeing the entropy created at each thing and the mixing of the RANDAO to generate unbiasable entropy, we can't advance the state of the art. And so unless we think this is the minimal proof-of-stake algorithm, then we need some way to prove that we can, to explain this system for everyone.
Yeah, so we're Beacon Thugs in Harmony, and we hope to that this simulation can help to advance the state of Ethereum 2.0. And we also found a potential vulnerability that we put onto our GitHub. So it's pretty interesting when you actually try to step through the logic and go from basic principles and really try to prove that this works. And I started being skeptical that it worked. And about 10 hours in of us just bashing our heads against this spec in this YouTube video, we had a eureka moment. We're like, wow, this really works. VDF is like really the way to go here. So,
Great.
Pretty exciting stuff.
Thank you so much. Any questions from the judges? looks like that's no. Oh, yeah,
Last
Taylor.
one.
Yep.
What do you think is like the best resource out there to learn about ETH2.0 and beacon chains and all of that?
Honestly, I think that the only way to actually learn this, it's so complex. There's no individual piece that you can understand that gives you the understanding without the whole picture. I mean, this integrates it faithfully. This would be a very good. We have a public GitHub for this. That would be, I think, a good way to start. You can see it faithfully implemented, so that you can see the actions yourself. I think that really that's the only way to understand this, as it is such a moving parts.
Thank you.
Thank you. Yeah, let's give a round of applause. And at the same time, welcome up synchronous cross